Hello my dear students, welcome to this next video. In this video we are going to discuss a problem which was there in GATE 2024 question number 14. So this question was from the subject of real analysis. So let us see what is the statement. It says that consider the following limit. So if you look at the limit which we have to calculate, so it is an integral and then we have to calculate the limit. So basically you have to first calculate the integration and then you have to calculate the limit, right. So combination of two concepts. So the it is a multiple choice question. It says which of the following is correct. The first option is limit does not exist. The second option is limit exists and is equal to 0. Third option is limit exists and is equal to 3, and the fourth option is limit exists and is equal to pi. So let us see. So if we look at the integral, so it is a combination of three parts in the integrand. So we will be doing each part separately. So if you look at the first part, it is e raised to power minus x divided by epsilon into cos 3x dx. So we have to integrate this. So we are going to use the formula. Integration of e raised to power ax cos bx is e raised to power ax upon a square plus b square into a cos bx plus b sin bx. So this formula, it is better to remember these formulas, because if you try to derive them, it will take some time if you are doing it in the exam itself. So there are 2-3 formulas like this, e raised to power ax cos bx, and then you have e raised to power ax sin bx. Only 2 formulas, so you can remember them, right. Okay. So I am going to use this formula here. So this is e raised to power ax divided by a square. A here is minus 1 by epsilon and b here is 3. So b square, and then you have a into cos bx plus b into sin bx, and then limits from 0 to infinity. Right. Now if you put the limits here, so when you put 0 limit, right, when you put 0 limit, you will see that this term will go away, because x raised to power 0 will be infinity. If you will put infinity limit, this will go away, because x raised to power minus infinity is 0, and so this whole term will go away. And when you put 0, so this term becomes e raised to power minus 0 upon 1 by epsilon square plus 9 into this is 0, because sin 0 is 0 and this is 1. So you have minus 1 by epsilon. So you have this thing epsilon upon 1 plus 9 epsilon square. Now this is the first part of the integrand. Now if we look at the second part, that is e raised to power minus x by epsilon into x square. So I am considering that integral. This is easy to compute. You just have to apply integration by parts. So here I have done first function, integration of second function, minus derivative of the first function and integration of the second function, right. And then here if you see, when you put epsilon infinity, x in place of x, you put the infinity, you get 0. When you put 0, because of this term you will get a 0, and here again you apply integration by parts. First you can just bring this 2 and epsilon outside, and then negative will become positive. Now here you again apply integration by parts. First function, integration of second function, minus derivative of first function, integration of second function. Here again when you put infinity and 0, both the terms will give you a 0. Here if you put an infinity, you will get a 0, and when you put a 0, you will get a 1, and 1 minus epsilon square in the because of this term. So you have 2 epsilon cube. So this is the second term, right. Now if you look at the third part of the integrand, so that is this e raised to power minus x by epsilon into square root of x plus 4. So you have this thing here, right. So here you have to do the substitution. Here what I am doing is I am putting x upon epsilon as u. So